This is question 2 of the midterm homework corrections. So this is a question 8, and my advice for an exam question like this is before even reading through the questions, you can nearly get a lot of the information that they're going to ask of you just looking at the mechanism that they've given you here. So first of all, I would identify my compounds. So A, I can see must be an alcohol because of the OH group. B has a functional group CHO, that is an aldehyde. COOH for part C, or molecule C, that would give me a carboxylic acid. And a COO in the middle of a compound indicates to me that that is an ester. Next, I would name those compounds. So the first one there, 2 carbons and an alcohol, that will be ethanol. The aldehyde has 2 carbons in it also, so that will be ethanal. The carboxylic acid has 2 carbons in it, so that will be ethanoic acid. And the ester is a bit more tricky to name. For that one, I would draw it out. So there it is, and I haven't put in the hydrogens, but there would be the 6 hydrogens in there as well. Now I can work with this looking at my alcohol side, which would be my parent alcohol, which would be from the single bond to oxygen, and my carboxylic acid parent molecule, which is the one that would have the double bonded oxygen on there. So looking at that and my rules for naming esters, I would be able to name this as methyl ethanoate. Taking the parent alcohol and changing the name to be named as a side branch, so methyl, and changing the ending of the parent carboxylic acid to OAte, methyl ethanoate. The next bit of information that I would deem important here is going from A to B to C to D, so the conversions X, Y, and Z. So first of all, what kind of conversions are they? So going from an alcohol to an aldehyde, that's an oxidation reaction. And going from an aldehyde to a carboxylic acid is also an oxidation reaction. There's lots of different oxidizing agents. The 2 that we have mentioned for these would be acidified potassium permanganate, or I'll write it on the next one, acidified sodium dichromate. So you could name either one of those in for either X or Y. Then going from the carboxylic acid to an ester, that's an esterification reaction. And what I need to do, as we discussed in the naming, is I need to take my carboxylic acid and I need to react it with an alcohol. And I think that about sums up all of the information I can put in here without looking at the actual questions. So looking at part A, I've done all of this already. I've named all of my compounds just looking at them in the beginning. Now that's a very generous 12 marks really. I'm not sure that we should bank on it getting an easy as that 12 marks. Whether you consider it easy or not, I guess, is totally subjective. Next, name the homologous series to which B and D belong. Again, we said that already. We said B is an aldehyde and D is an ester. Then C, identify the compound which contains only tetrahedral carbons. So we actually didn't do this. So tetrahedral carbons are carbons that have 4 single bonds coming from them. So that's a tetrahedral carbon. The other one we've seen is a planar carbon, and that's going to have a double bond in it. If we were to draw out all of these, I'll just put it up in part A here in red. Ethanol would have OH, and the other carbon would have all single bonds to hydrogen. So we can tell already that that has all tetrahedral carbons. Ethanal would look like this. Ethanoic acid, COOH, and methyl ethanoate we drew out on the last slide if you want to jump back and have a look at that. And that also has a carbon to oxygen double bond in it. So the only one with all tetrahedral carbons is ethanol. Next, we also classified our conversions as addition, substitution, or oxidation, I suppose, other than the last one there. So the conversions here from ethanol to ethanal, we said that that is an oxidation reaction. Going from ethanal to ethanoic acid, that is also an oxidation reaction. And the final one there, from ethanoic acid to our ester methyl ethanoate, is a substitution reaction. We are substituting the H of the COOH in the acid with a carbon chain. So when we were discussing esterification, we would have said it was a substitution reaction, or you could have said it was a dehydration reaction because water is removed. Finally, name the reagents used in the conversion B to C. We did actually mention those on the last slide. Your answer would have been acidified potassium permanganate or acidified sodium dichromate. Part F is asking us to name and draw an isomer. So an isomer is a compound with the same chemical formula but a different structural formula. And they've asked us to draw the carboxylic acid isomer of compound D, which is our ester. I've just copied the diagram of that from previously in the question. And chemical formula refers to how many atoms of each element there are in the molecule. And so here that's C3H6O2. And what they've asked me for is a carboxylic acid. So I know in a carboxylic acid, I'm going to need to have a COOH group on the end. I can then fill in the rest of the chemical formula using a carbon chain. So I'll put in how many carbons I have. That's 3 carbons. I've already accounted for my 2 oxygens, and by filling in the 4 bonds required by the carbon, 2 hydrogens, I can account for the 6 hydrogens there. So this is an isomer of that original compound D. They've also asked me to name it. For a carboxylic acid with 3 carbons in it, my name is going to be propanoic acid. Question G is asking us about the reactions of a carboxylic acid with sodium carbonate. This was part of our mandatory experiment on carboxylic acids. And what we will have there is the ethanoic acid reacting with the sodium carbonate to make the carboxylate salt. So the OH in the carboxylic acid will be replaced by the sodium, and we will form water and carbon dioxide. So that looks like CH3COONA plus H2O and CO2. Now, to balance that, I have got 2 nitrogens on the left, so I will need to multiply whatever is on the right with sodiums. I think I said nitrogen there, sodium on the right to balance that out, and that will mean I'll need 2 of these here as well. And that's my balanced equation. If they were to expand on that last question, The other part of the experiment was about testing the products. And the test here would be for carbon dioxide, that you would test the gas given off. It would turn lime water milky.